Moving into lesson 3 for chapter 16, we are now looking at shapes or two-dimensional shapes within the three-dimensional shapes that you see here. So this is where this is more of the test level type question that we need to get to. In the previous two lessons where we were just dealing with right triangles, kind of all that basic right triangle information, this is how it would now be applied. And so this is kind of the common use that you can expect to deal with those areas for right triangles. So it's just to point out a couple things with the shapes that you see here, starting with this guy. So these are now all about finding right triangles and right angles within diagrams like this. And so when you see a prism like the one that we see here, this is going to be all about identifying right triangles within this shape. So they may ask you for things like diagonal HF, right, for something like that. And obviously we want to recognize right here that this corner is a right angle. We have a rectangle on top. Looks like we potentially have squares on the sides. So just things like that, we got to find the right angles within these shapes. Now obviously visually, two-dimensionally, that doesn't look like a right angle, but if we can visually recognize that that is a three-dimensional prism, that the top is a rectangle, the bottom is a rectangle, things like that, then knowing that those are rectangles, we can identify the right angles within the diagram in a case like that. And so this is all about just drawing in the lines that they're asking us to identify, creating right triangles so that we can use our right triangle knowledge to solve for things. So again, the same would be true on this shape right here. If you see triangle DFE, so again, one thing we want to recognize that DF is a vertical line and EF is a horizontal line. So naturally, we know that this angle F that we see right here is a right angle. So we have a right triangle on the right side of this. We have another right triangle on the left. So those are right triangles we could identify. They may ask us for angle measures, not just side lengths. And so if they wanted this angle, say right here, angle FED, so this angle right here in the corner, again, it might take using an inverse trig function to find those things. So anyway, here's one diagram that I just wanted to point out because this is sort of a good drawing. So in this case right here, they were talking about identifying this angle measure. So again, notice that this angle in the back where you see the Q is a right angle. And so we might have to use a little inverse trig to find something like that. So anyway, we're going to take this example right here, and I'm going to follow through on my handout to start finding a few things. But if you look at the drawing that we have, so we're going to find these three pieces of information. So the length of segment AC. So if you take a look at AC for a minute, right, we want to find that segment. And again, this is going to be about identifying right angles like this one down here that we can use to find that kind of information. So these are the three things we're going to do here on the notes page. So here is the cube, and it says, right, we have like the base is a square, so on and so on. And so we want to use that information to now find whatever they want us to find. So this is one of those cases where it's hard to give you every possible example that you could run into, but I thought this was a good sampling of questions that we're going to need to be able to handle. So if we look right here, so it did say that the base is a square. So if I'm trying to find the length of AC, which is what we're doing for part A, well, if we recognize that this is a square, then again, notice this is a right angle that we have sitting right there. And so two things, you could use Pythagorean theorem and do 6 squared plus 6 squared equals c squared or x squared or whatever you want to call that. So Pythagorean theorem would work to find that. If we know that the base is a square, well, then the other thing you might recognize then is when you draw in the diagonal and these guys are equal, that makes these two angles equal. These are both 45-degree angles. So we also have a 45, 45, 90 triangle, which means if our legs are 6, that makes the hypotenuse 6 root 2. And so that little 45, 45, 90 shortcut is kind of nice as well. So you could either use Pythagorean theorem or a little 45, 45, 90 knowledge, and those would be the best ways of figuring out segment AC. So in this case right here, so now for part B, what they're asking for. Let me go back to the other page so you can see it. So now for part B, it says what is the length of diagonal AG? And so looking back at our handout for that, so if we are looking for the diagonal for AG, again, this is all about identifying right triangles within the drawing. So you can see the diagonal that was drawn right here from A to G, or right here from A to G, and you can see that how we're using some information that we already know, like we knew this was 6 radical 2. We know this is a length of 6 because we had a cube, and so we've identified a right triangle within this drawing that can now help us. Keep in mind, there's more than one right triangle you could identify here, so sometimes it's just going to be a matter of finding one that works for you. So in this case, I now know that this is 6, I know that this is 6 root 2, and now I could use a little Pythagorean theorem to find AG. So that's another option. There may be other ways, but this is one way of doing it. So it's kind of, I like this diagram because they kind of shade in the right triangle that we would need to identify. Obviously, that's not going to be there for you. That's something we're going to have to visually be able to find on our own. So anyway, at this stage, if we did a little Pythagorean theorem, so we can do our 6 squared plus 6 radical 2 squared is equal to AG squared. So we can set up that guy right there. If we do a little simplified cleanup on that, we're going to find that AG is the square root of 108. And obviously we could leave that as a radical. We could do a little rounding to 3 sig figs. Just depends on what the problem may ask us for. Remember, on a test, either exact or 3 sig figs are accepted unless the directions say otherwise. So in this case, the directions aren't specific, so we could write it either way. However, if you find that you're going to use this knowledge to do something further, which we may, if so, you want to go with the exact answer as you move forward. You don't want to use a rounded answer to do something else. So keep that in mind. So let's see what they're looking for part C. In part C, it says the angle that the diagonal AG makes with the base. So if we see within our drawing, and they've already kind of identified this for us, but they're now referencing an angle measure, and it said the angle that AG forms with the base. And so they connected now that extra line that it formed with the base, which is AC. Right, and so that's the one that they're referring to. So we're looking at this angle right here. Within that triangle, we've already identified every value within that little triangle, and so you have some options here for your approach, but any inverse trig function would work for finding that angle measure. So I'm just going to pick one. You know all 3 sides, and so you could use any trig function you want, and we're all going to get the same answer for this. So let's just say I wanted to go with the tangent function. So we're going to use an inverse tangent function since I'm looking for an angle measure, and tangent is opposite over adjacent. So we're looking at the inverse tangent, of 6 over 6 root 2. And so if we go into your calculator, type in the inverse tangent of 6 over 6 radical 2, we get our angle, which is about 35.3 degrees. To 3 sig figs. So again, this is kind of the main idea for today. I'm going to show you one more example, but this is the main idea that we need to take away from this lesson. And again, all this is about identifying right triangles within the drawings that we can take advantage of. So moving on, let me show you one more example. So here's one that's sort of a little more complicated version of just working with right triangles within an example like this. Again, the nice thing about this one is that it's already drawn for us. We don't have to come up with our own drawing here, but you're going to see one just like this in the homework, so it's kind of nice that we already have it drawn. They even labeled the values already. So, for example, this is 30 degrees. That's referring to this angle right here. We got the 20 degrees right over here for angle Y. We know that from X to O is 200. All those things were identified up here within the problem, and they already labeled it for us within the diagram. One thing that we'd want to note right off the bat is anytime you are doing things that are north and south compared to east and west, those are always perpendicular lines. And so we got to recognize a few right triangles within the diagram that we see right here. So for this particular problem, they want to know how far apart are points X and Y. And so ultimately what we're looking for is, let me do this in a different color, is the distance from X to Y. So this is the line that we are trying to figure out, is that length for XY. But we're going to need to come up with a few other numbers before we can get to this one. So one thing I did mention again is anytime you have north and east, right? Anything running north and south compared to east and west, we need to understand that that would naturally be a right angle because those are perpendicular lines. So I do have a right triangle right here. Notice that I know this is 200. So if I know this is 200, if I can come up with the other segment right here, then I could use Pythagorean theorem to get this red line. So again, it's just about identifying a right triangle and then coming up with enough knowledge about the right triangle to use it in order to find what you want to find. So in this case, let's just start going through and finding whatever we can. We may not see the answer right away, but let's just start finding whatever we can find. So one thing we see right here is I got a vertical line right there, right? So if that's a vertical line and this is the ground, then those would naturally form a right angle also. So I got another right angle right there. So looking at this, I know this is 200, I know this is 30. We could come up with this value right here with either using tangent of 30, right, equals opposite over adjacent legs, or if I recognize, hey, that's a 30-degree angle, so that means I have a 30, 60, 90. So if 200 represents my long leg, right, then I can do 200 divided by rad 3 to get my short leg. So you could do that with either your 30, 60, 90 rules, or you could use a tangent function and get it that way. So I'm just going to identify my height here as 200 divided by rad 3. Just using my 30, 60, 90 rules, I can come up with that one. If I now look over here to the right, notice they also gave me another 20-degree angle right here. So I see another right triangle taking place over here. So I got this right angle here. So I got another right triangle on the right side. Again, I could use like something like a tangent function in order to get this y value. So based on this angle right here of 20 degrees, if we said tangent of 20, all right, and from here I could say opposite over opposite over adjacent. So I got my 200 root 3, 200 over root 3 divided by y. So we can use that setup right there to now solve for my y value. And so if you were to plug that into your calculator, you would get the y value, which equals about 317. And I'm going to go a little deeper, 0.251. Remember, it's always best to go a little deeper with your decimals until you're done with the problem. So I'm not rounding to 3 sig figs until the very end. That way I get a more accurate answer. Anyway, we now have enough information to use a little Pythagorean theorem here on this red line. Right? I know this is 200. I know this is the y value that we just found. And so now I can use those with Pythagorean theorem to get my red line. So I'll do one last setup here. So if I did 200 squared plus my y value squared, and that's going to equal that red line, which we'll call xy. So there's our setup to now get xy. A little cleanup on that, and we're going to get that guy being about 375 to 3 sig figs. And so ultimately that's what we were trying to find. Notice if it's a drawing like this, or even one of the drawings like we see up above, sometimes it's just a matter of, if you don't see how to get the answer right away, just solve for whatever you can solve for, and then oftentimes at some point you're going to say, okay, now I can see it, I have enough information to find what they're asking me to find.